In this lesson, you will identify complementary, supplementary, adjacent, linear, and vertical angle pairs. You will also algebraically calculate the measure of angles. Before we begin, I want to remind you that angles can be classified according to their degree measurements. You can see here that an acute angle is an angle that measures less than 90 degrees. A right angle is an angle that is exactly 90 degrees. An obtuse angle is greater than 90 degrees and less than 180 degrees. And then finally, a straight angle, which is exactly 180 degrees. Now let's look at some special pairs of angles that are classified according to their degree measures or sides. The first pair of angles we're going to look at are complementary angles. They have angles whose measures total 90 degrees. Each angle is a complement of the other angle. The next pair of angles are supplementary angles, whose angles have a measure that totals 180 degrees. Each angle is said to be a supplement of the other angle. Adjacent angles are two angles in the same plane that share a common side and a common vertex, but that have no interior points in common. Angles forming a linear pair are two adjacent angles in which the uncommon sides are opposite rays. The angles of the linear pair are supplementary. Now, vertical angles are two opposite angles formed by intersecting lines. The vertical angles have equal measurement and are congruent. Congruent means they're equal in value. Their measure is exactly the same. So angle 2 and angle 4 are congruent. Angle 1 and angle 3 are congruent. This is a rule that governs any two intersecting lines that the opposite angles will be congruent. All right, let's take a look at some examples of what might be in your homework. All right, the first example I give you is, I tell you that angle F, right, that's the vertex, so we can write it angle F, and angle G are complementary. Do you remember what it means to be complementary? Complementary means that the sum of angle F and the sum of angle G's interior angles is going to equal 90 degrees. Okay? So what we know here is that this one is 42 degrees plus x over 2 equals 90. That's right, folks. You're not going to be able to outrun the idea of solving for x. That's algebra. So let's go ahead. We're going to go ahead and subtract 42 from both sides of the equation. Okay, I'm going to subtract 42 from both sides of the equation. And what I'm going to get is x divided by 2 equals 48. Okay, 48 degrees. Remember what I do next? Any ideas? You're right. If you guess divide both sides by 2. Now that I've multiplied both sides by 2, that leaves x by itself, and 2 times 48 is 96. So that's what x equals, 96 degrees. So we can say, for this problem, that x here equals 98, because 98 divided by 2 is what? 48. 48 plus, so let's just plug it back in here. 96 divided by 2 is 48. 48 plus 42 is 90. So that works. Okay? That's how you do this problem. Again, you just want to set it up. We know that these two angles are going to equal 90 degrees because they are complementary. That's what complementary means. So we know that the measure here is 42. We know that the measure here is x divided by 2. And the sum of both of those equals 90. Then you solve it like an algebraic equation. Okay? And just plug it back in to check that it makes sense. All right. I know that was a little quick. Let's look at example 2. Uh-oh. Same type of thing. Do you remember what supplementary means? You got to memorize this, guys. There's no way around it. Supplementary means that the sum of the angles is equal to 180. So we know that the measure of this angle and the measure of angle I is going to equal 180 degrees. That's what supplementary means. So we know that h is 126 degrees plus 2x degrees equals 180 degrees. All right, so what do we do first? That's right. Subtract 126 from both sides of the equation. You're going to get 2x equals what? Any ideas? I'll pause for a second to let you do it. 54. Then I'm going to go ahead and divide both sides of the equation by 2 to isolate the variable. And I'm going to get x equals 52 divided by 2, or what does that equal? Any ideas? Well, 2 goes into 5. How many times? 2. With 1 left over, goes into 14 7 times. Okay, now we could figure this out. We could plug it back in here and do the math, and you'll find that it does, in fact, equal. Well, let's go ahead and do it. So we know 126 plus 2 times 27 equals 180. Let's just check our work. Okay, what I'm doing is I'm taking this and plugging it back into this original equation. So if you add this, 4 and 6 is 10, carry the 1. 6 and 2 is 8. So yeah, that's correct. That is absolutely correct. Okay, smiley face. All right, kids, you want to look at another example? All right, so based on this scenario of two intersecting lines, we know that angle CWB is congruent to angle AWD. Okay, both of these angles are equal. They're congruent. So we're going to set up this equation right here. Okay, what I did was I took the measure of angle AWD and set it equal to the measure of angle CWB, or BWC. And then what I did, the first thing I did, now I'm going to try to isolate for the variable, okay? The first thing I did was subtract 10 from both sides of the equation. And that gave me 3x equals x plus 40. Remember, when the signs are different, you keep the sign of the larger absolute value and you subtract. Okay? Then the next step, I went ahead and added 1x to both, or subtracted 1x from both sides of the equation. And what I got was 2x equals 10. Now, I just caught my error. Does that look right? No, it doesn't. So I'm going to go ahead and fix that right now. 2x equals 40. All right. Now, let's continue from there. Scoot this up just a little bit. I'm going to go ahead and divide both sides of the equation by 2. And what I'm going to get is x equals 2 goes into 40 20 times. All right? So far, so good? So how am I going to now, with this new knowledge, figure out what the measure of angle AWD is? You got it. I'm going to take the 20 and I'm going to plug it into this. All right? So let me do that for you real quick. So what I'm doing here is we know that x now equals 20. I'm going to plug it into this equation. So 3 times 20 plus 10. Okay? So we know that 3 times 20 is 60. And those added together is 70. So we know that the measure of angle AWD is 70 degrees. Okay, that's what the M here means. The measure of angle AWD is 70 degrees. So if this is 70 degrees, we also know that this is 70 degrees. Okay? But that's not what it was asking. It was only asking for the measure of this angle. All right, guys. You ready for another example? Let's do it. All right. In this example, they're asking, well, very simply put, they're asking what is the measure of this angle. Well, that's interesting. Well, what do we know about this so far? Do we know anything here? We do know that the measure, okay, and I'm going to use a highlighter to kind of make this very easy to see. We know that this angle here, the measure of angle ABC, okay, this right here, the whole thing measures this, okay? And there's one more thing we know that I forgot to put in. We know that the measure of angle CBD is 65 degrees. All right. So if we know that this measure here, this whole thing, the measure of this entire angle is 112 degrees, we know that this plus this is going to give me 112. So here's how we solve it. I'm going to go ahead and put the question mark here. Plus 65 equals 112. All right? Well, I'm going to go ahead and subtract 65 from both sides of the equation. And what I'm going to get is, any ideas, guys? 47 degrees. All right? So we know that the measure of angle ABD is 47 degrees. Pretty simple, pretty straightforward. Again, you have to be very, very familiar with the information. These are adjacent angles, obviously, okay? They share this ray, but again, the sum of these two is given to us. The sum of both of these, the sum of both of the interior angles is 112 degrees. Then they tell you what one of them is 65, and you can easily set up an equation to solve. All right? I've got two more examples for you. Okay, so it's pretty obvious what they're asking, but they're telling me that this right here is a line, okay? So they're also showing me that there is a ray coming out of that line, creating two angles, okay? What do we know about these? We know that these angles have to be supplementary, okay? We know that they're supplementary. Well, because they are supplementary, we know that the measure of angle DEG plus the measure of angle FEG equals 180 degrees. Okay? This is a linear pair, and because they're a linear pair, the measure of these two angles is supplementary. It's going to be 180 degrees, okay? And again, you need to use those rules. Get a cheat sheet with you. Use those rules. So we know that the measure here is 49 degrees plus, and I'm going to make this x because I don't know. Okay, that's the variable I'm going to use for this. Equals 180 degrees. All right, to solve for x, I'm going to subtract 49 from both sides of the equation. And x is going to equal what, guys? 131? Is that correct? Again, half extra credit point for anyone who catches me making an error. So we know that the measure of this unknown angle is 131 because the sum of both of these has to equal 180. Okay? Last example, I promise. Video's getting long. Oh, snap. What do we have here? Well, we have two lines that have intersected one another. Okay? And, you know, for the purposes of this example, let's try to make this a little more interesting, okay? Let's call this 3z degrees. We don't know what it is. We know it's 3z degrees. Well, you might be asking, why, Mr. Arnest, are you making this complicated on me? Because I'm committed to your learning, and I want you to see an example like you might encounter in homework. Well, we know that these are two intersecting lines. Okay, that's pretty obvious. And we know that in examples where there are two intersecting lines, the opposite angles are congruent. Okay, they're equal. So we know that 39 is going to be equal to 3z. Well, how do I figure out what the z value is? Well, simple. I divide both sides by 3, right? And what I'm going to get is z equaling 39 divided by 3, which is what, guys? 3 goes in 3 once, 3 goes into 9, 3 times. So the z value is 13. That's what this value right here is, 13. Okay? That's what it's asking you for. So I hope this helps, and we'll chat soon. And if you have any questions, write them down so that we can get right to work and I can help you when we meet up. Good luck with your homework. Don't forget to check Google Classroom for due dates. Till next time, thanks for watching.